In this video, I'm going to show you how to find the limit numerically or by table. So in the previous video, I showed how to find the limit using the graphical approach or the wall method. So in this video, I'm going to be finding the limit using a table. So we still have the same graph here in this pink graph here, and is represented by this function. F of x is equal to x squared minus 1 over x minus 1. So how do we solve this using a table? So the first thing we need to do is draw an x and y table. So in this case, our y is represented by that f of x, which is equal to x squared minus 1 over x minus 1. Now, it's going to be really helpful if you have a graphing calculator to solve this problem. So I would enter this f of x function into the y equals of the graphing calculator. Then what you want to do is, so the first step here is steps number 1 is type in the graphing calculator y is equal to x squared minus 1 over x minus 1. Number 2 is you want to change the table set. So you would go to second and then window, okay? And which is basically the table set. All right. And you're going to go to independent, the independent row there, and then change that from auto to ask. Okay. Next, you're going to go to the table. So you hit second and graph to do that. So second graph, and that will bring you to the table. Now, the hardest part is to figure out, okay, what values do I plug in for x to find out what the limit is? So in this case, what we're looking for, just as we did for the graphical approach, we want to find the limit as x approaches 1 of that function of f of x. Okay. And as I mentioned before, we need to look for the left side of the graph as well as the right side of the graph. So in this case, I need to find the limit as x approaches 1 from the left side of the graph, and I need to find the limit as x approaches 1 from the right side of the graph. So let's focus on the left side of the graph. So here's x is equal to 1. There's 1 there. And I want to find out as x approaches 1 from the left side, right? That's what that negative sign means. As x approaches 1 from the left side, what is that value going to? So in this case, I need to enter values that are close to 1. So the left side of 1 will be numbers like 0.9, 0.99, 0.999. Okay, so I'm going to enter those values in my table, and it's going to spit out my y value. So in this case, when I enter 0.9, it spits out a 1.9. When I enter 0.99, it gives me 1.99. When I enter 0.999, it gives me 1.999. Okay, so it appears that as x approaches 1, so as x approaches 1 from the left side, y is getting closer and closer to 2. Okay, so as x approaches 1 from the left, y is getting closer and closer to 2. So we would write down 2 here. Now I'm going to do the same thing for the right side of 1. So that's what, again, that plus sign means. So I'm going to get closer to the 1 from the right side. So numbers that are close to 1 from the right side are 1.01, 1.001, and then 1.0001. Okay. And as I enter those values in my table, I get 2.01, 2.001, 2.0001. Okay, so it appears that as x approaches 1 from the right side of the graph, the y value is approaching 2, or the limit is going to 2. Again, as x approaches 1 from the right side of the graph, the limit is approaching 2. So here I write down 2. Okay, so what's our conclusion? Well, we can say based on the table, so based on the table, okay, the limit of f of x as x approaches 1 is equal to 2. And that's how I would write my work or my answer here. In the next video, I'm going to show you how to solve this or find the limit algebraically.